So welcome everyone to, I think most of you were here this morning actually for the tutorial, so you will know everything now. But we're going to tell you a few things that weren't covered in the tutorial actually. So I'm Ian Foster. I lead the Globus project along with Steve Tiki and actually a bunch of wonderful people, many of whom you will meet. But I've been charged with providing some introductory remarks, explaining what we've been doing with Globus over the last year or so, and what we're planning to do next. Before we start, for those of you who feel nervous if they don't have some social media contacts, here's some information so you can tweet and tell your friends how exciting Globusworld is. Enough said about that. So I think why are we here? I will start off with a high-level picture. So our goal, as we say on this slide, the goal of the Globus project is to address this challenge of managing data throughout the research lifecycle. And this is a challenge because, well, for lots of reasons. One of the reasons is just the, oops, that goes forward automatically. That's annoying. The huge data volumes that we're facing. So I think we're all deeply immersed in that challenge. Many of us have been deeply immersed in this challenge of enormous data volumes for a very long time. Our view is that when faced with the problem of managing large amounts of data from the point of when it's produced to the point of when it's aggregated, consumed, analyzed, eventually published, shared with others, it's not something that we can keep doing. It's not something we can achieve success in if we keep proceeding along the ways that we have been in the past. So I referred to the words of a great American philosopher, Frank Zappa, and he observes, he says, without deviation from the norm, progress is not possible. So what I'm going to try and explain to you today is how we in Globus are taking what we think is a slightly different approach to what people have previously taken to problems of research data management. And the key to this new approach is this use of what we may call cloud-hosted services. So Globus, as we conceive of it today and as we have been talking to you about since early this morning, its goal is to simplify research data management, as I said. And the approach we are taking is to leverage the power of cloud-hosted software as a service. So why does that matter? Well, think about some of the cloud-hosted services that we routinely use. For example, Amazon. And here I'm not referring to the Amazon cloud, but simply to the Amazon machine, the machinery that sits under the Amazon website when you go to buy a book online. So we had a wonderful talk a few years ago by Werner Vogels, a senior architect, I guess chief technology officer at Amazon, and he recounted the fact that when you go to an Amazon website, there's something like 200 or 300 individual services that get invoked to present to you the information that you see as you presumably, hopefully, go and buy ultimately a book, which is then delivered to your home. So there's some very sophisticated and powerful logic there, logic that I don't think any of us could hope to reproduce in our individual homes or small businesses. We as users interact with this very sophisticated logic via web interfaces. In some cases, we may also interact with them if we're a third-party consumer of those resources via an API. The result of these interactions is some very wonderful things that happen in the world. Books move from one place to another. The gifts are delivered to our family and friends and so forth. We're not aware of that complexity and sophistication that sits behind the covers of this website because of the power of cloud-based services. There's the fact that there's a single copy of this software sitting on a set of computers, in Amazon's case, a very large set of computers that are designed to be highly reliable internally, thanks to techniques like replication and so forth, and that are designed to be highly simple for end users. Sometimes the Amazon website doesn't seem so simple, but in many ways it is. And this is all possible because well, in part because of economies of scale. The fact that Amazon can do this for themselves, they can then do it for hundreds, thousands, tens of thousands of other companies. So that's Amazon. Of course, we're not interested in book selling, we're interested in research data management. But our belief in the Globus project is that we can we can leverage some of the mechanisms, the methods that are applied in commercial cloud, such as Amazon, and leverage the methods that they use to achieve these goals of simplicity, reliability, and economies of scale to do something similar for research data management. And that's what we've been doing over the last several years with Globus. We've been working to deliver a pretty small set of services: data transfer, data sharing, and now, as we'll be describing, data publication and discovery, all with logic that we run actually on Amazon computers, it turns out, because Amazon, of course, is not just a bookseller, it's also a provider of cloud services. The logic sits on Amazon. The data, though, can sit wherever you want, on storage chosen by you, on your own home institutions' computers, on your laptops, on Amazon or other cloud storage, if you like, on National Center storage. And in so doing, we believe, and I think the indications are we're being successful in this regard, we believe that we're able to introduce a level of simplicity, reduce the costs associated with research data management, and provide a degree of reliability that would not previously be achievable. Okay, so let's say just a few words about what Globus does. So most of you have heard this already this morning in the tutorial. So I've got one slide that summarizes sort of some of the key functions that we seek to deliver. So the research data lifecycle is, of course, a vast and complex end-to-end process that may involve many actions. We've focused on a few initially that we feel are particularly time-consuming, error-prone. For example, data transfer. So there are sort of two classes of people in the world: those who never think about data transfer and don't think it's a problem, and those who have to move lots of data from one place to another, and they realize it's a very big problem that can consume a lot of their time, especially if they don't have a grad student or postdoc or programmer to ask to do it for them, which unfortunately is the case for some of us. And then so those grad students themselves may not want to be given the task of moving 1 million files from one place to another. So our data transfer services address the challenge of moving data from A to B reliably. As we show here, those two places might be a light source or other experimental facility and a compute facility or someone's home lab machine or a national research computing center. Wherever those two places are, we allow people to interact via a web interface, and if you like, as easily, perhaps more easily than ordering a book on Amazon, you can ask that data be delivered from one place to another, and it will happen. If your data isn't too big, you'll get it to your moved even faster than you would get a book delivered by Amazon. If it's big, some transfers we've seen have taken weeks. I think the record is about 3 months for a very large transfer involving many millions of files and I think about 1 petabyte of data. So the user asks for data to be moved. Globus transfers the data reliably and securely and then notifies the user when things are finished. So hopefully you've all seen this at work and you're quite familiar with this process. The next component of the Globus service, which we added subsequent to transfer, is sharing. So we observed that while people often want to move data from A to B for their own purposes, often, especially when it gets to B, they want to then be able to make it available to other people, to members of research collaboration, to their colleagues. And often those people don't have accounts on the computer systems on which the data is located. So we added sharing support, which basically allows the owner of a piece of data, as we say here, the PI, but basically whoever owns that data, to specify the particular file or files or directory or directories should be shared, indicate who it should be shared with, and what permissions that person or persons or groups should have on that data. Once that is defined, then Globus goes ahead and controls access, and those people can then, the people with whom sharing has been performed, can go and access the data. They can download it if they've got appropriate permissions. They can upload data. They can replace data sets with other versions and so forth. So it's much like some cloud-based systems like Dropbox. A big difference is that you don't need to move data to cloud storage in order to do this. So it works off your institutional storage repositories, for example. So then the latest thing we've been doing, and as you can see, we're gradually trying to fill out more of the end-to-end life cycle, is addressing issues of publication. So we move data just purely for our research. We share it with people who we know well, and we just need to tell them, well, that data we produced yesterday morning, it's now available on the site. The next more structured aspect of data sharing is data publication, where we want to put data somewhere along with a set of metadata describing it, and perhaps also guarantee that the data is immutable, that it has been curated, that it satisfies certain quality control standards. So this is our data publication services, which we'll be saying more about. We'll be demonstrating them in a minute. So here the idea is that we take, so far what have we hosted on our cloud-based services? We've got data transfer management and sharing management. Now we add in data publication workflows, workflows that the owner of storage can configure to specify, well, do you want someone to curate this? What metadata do you require, and so forth. Once that has been specified, then any authorized user can come in and assemble a data set, provide some metadata, for example, Dublin core or other domain-specific data, and move it to a repository. Once it's there, the final step, data discovery. So we add in, as a final step, data discovery support. So now we can take metadata that's been associated with a published data set, move it or copy it into a catalog, and now we can start searching data. So there's certainly more to end-to-end data management than these steps, but we have got to the point where we can provide support for every aspect of the process, from getting data, producing it at an instrument or a simulation or other device, and delivering it into a catalog, into a repository, and allowing other people to discover it and access it. And of course, all of this is done using this cloud-hosted software as a service, SaaS. You only need a web browser in order to access all this functionality. You don't need to install software beyond the Globus Connect services, which you read about this morning. You can access using campus credentials. We monitor and update you on what's going on throughout. So it fits very nicely, we believe, and I think people tell us, into the work processes of real working scientists. Okay, so that's a few words about Globus. What has been happening over the last year? Well, first of all, from a user perspective, people have been doing all sorts of crazy things. They've moved a lot of data. Some people have gone all out on the goal of generating more transfers than anyone else. So a group at NYU generated 400,000 transfers during a 2-month period. That's probably the most transfers that a single person has performed during that period. It's not the most data that people have moved during that period. We see data being moved worldwide. So I put here a couple of maps. Everyone in Globus knows I like maps. And I keep asking for maps. No one generates them, so I have to go and make them myself. It's a shocking process. And I learnt Python along the way, so I have to show them to you. So this is, what are these maps? So this is, this red dot here is a particular beamline at the Advanced Photon Source, which is a scientific facility about 1 kilometer from here. And this red dot down here, which looks like it's in the same place probably, is the Blue Waters supercomputer in Urbana-Champaign. And these pictures, both, this is a zoomed in version of this, each show the destinations for data shipped from this site and this site over a certain period. I'm not exactly sure how long it was. So you can see during this period here, from this one APS beamline, data moved to 119 destinations, from Blue Waters to 300 destinations. So people really are using this service to move data worldwide. And I'm very pleased to see also that they're moving data to New Zealand, which is my original home country. Blue Waters is not, for some reason. We need to work with them on that one. And I did produce one other beautiful Python image, so let me show this to you. So this is a very mysterious looking picture when you first see it, but I think it's sort of interesting. So this is the amount of data moved in it. So this shows about 1 million transfers performed over the last couple of years. This is the size of the transfer. So you see the biggest one up there is about 200 terabytes. This is the great circle distance from the source to the destination. So you can see the furthest we've moved data is about 20,000 kilometers, or maybe 18,000. And then the color shows the transfer speed. So you can see the fastest transfers tend to be the biggest ones. But even over long distances, people are achieving quite high transfer rates. And then I labeled just a few points. These are transfers from the APS beamline to Western Australia, Eastern Australia, the US, and so forth. So one question is, why are there no dots here? It's a puzzle. I've asked audiences before, so you probably, and it's not that difficult to work out. But why are there no transfers of exactly 5,000 kilometers? What? The ocean, right? So yeah, so there's very few research sites that are exactly 5,000 kilometers apart because of the Atlantic Ocean and the Pacific Ocean. Okay, so that's so people have moved lots of data. We've been moving data very fast. So this is and it's sort of an extreme case of this. So Raj Ketamuthy and his team at the supercomputing conference were moving data using GridFTP. That's the transport protocol that underpins Globus services at well, a sustained 85 gigabits per second disk-to-disk performance rate over quite a long distance from Canada down to New Orleans. Of course, most of us don't yet have 100 gigabit per second networks, but when we do, I think it's going to be very impressive to see what we can do in terms of moving data end to end if you have the right end systems. In other sort of more quantitative measures or aggregate measures, we continue to see large amounts of data transferred. So we're up to about 85 petabytes moved so far. So one question for you to puzzle over today is, when will we get to 100? So probably in about 4 months' time, 3 to 4 months' time. You can see a pretty steady increase, probably slightly increasing rate of growth. A few odd increases here, which are probably associated with conferences or something. I'm not quite sure, actually. There's another, this shows the number of new user registrations. So this jumps around a bit. So here we see the very beginning. We launched, a number of people signed up, gradual growth. We got big enough where someone learned how to build a bot to try and auto-register with the service. So we suddenly jumped up that month. We got that under control and then resumed, and now we seem to be moving up fairly steadily. December usually is a slow month. I think this is December, but otherwise steady growth in the number of users. And perhaps more importantly is the steady growth in the number of people who are using it repeatedly. And so here's one measure of this, the number of active endpoints. So what's an active endpoint? So we have tens of thousands of endpoints that people have installed. Some people use them every day. Some people only use them occasionally. If we define an endpoint as being active, if it's been used for one transfer in the last month, then we get about 500 active Globus Connect servers. So these are typically major institutions, research labs, etc. And probably about 1,000 active Globus Connect personal servers. So a fair bit of use, and as we said, we're pleased that the the rate of growth continues to increase. Okay, so that's just a few words about what people have been doing. Now I'd like to start zooming in on some details of what we've been up to within Globus over the last year. So when we last talked, some of you I know were here last year, many of you are not, and so we're glad to see both of you. We described, we gave a little demonstration of our Globus publication service. So over the last year we've been working very hard on implementing that. When I say we, I don't mean me, I mean the people who do the actual work in the team, some of you whom you'll meet. And we've got to the point where we now have a pretty robust Globus publication, Globus data publication and discovery service underway. So to remind you, what this is about, what we want to do is to capture in a cloud-hosted, highly configurable, reusable form, because it's cloud-hosted software as a service, the workflows that one may follow if one wants to take some arbitrary pieces of data, bundle it up together, put it somewhere where presumably it will stay for an extended period, along with associated metadata so that it can then be discovered by others and accessed by others. And so as if you read the fine print here, you can see it. We talk about, first of all, a researcher assembles a data set, describes it in some appropriate manner. So you'll see in a minute how we go about doing that. Once it's ready, there's a curation step, where you can allow or require some project member, for example, it could be the PI of a project, to approve it, in which case it is then published to wherever you want it to be. And then finally, people can go ahead and search and discover it. So we announced this, as I said, a year ago. We've been working, first of all, to build stuff, and now, over the last several months, working increasingly hard and closely with a set of early partners. You'll hear from a number of those during the conference today. And we expect this to be generally available next month, so it'll be, you can all try it if you wish. So let me say a few words about what we build into the system. So we view publication as encompassing sort of the following steps. So you need to identify a set of data. So you've got a set of data. It might be, my holiday photos, or more likely, the results of my experiment at the Advanced Light Source at Berkeley, or something like that. You want to give it an identifier. You want to describe it. You want to enable people to access it, and you want to ensure that it's preserved. So we have basically implemented a system in which we can allow for a variety of choices along each of these axes. So an identifier can be a digital object identifier, a DOI. This is a fairly heavyweight formal means of defining data that is intended to live for a long time and be immutable. At the other extreme, data that you just want to share with some colleagues, but in a searchable and discoverable manner, you might want to represent simply using a URL. And so we also integrate support, as we explain, for the bit.ly URL system. The description that's associated with the data, there may be none in some cases. It could be some standard metadata, such as Dublin core or data site standard metadata. It could be domain specific, something specific, for example, to the climate or genomics or ecosystems, or it could be something totally custom. And then once people have provided data and metadata, then there may be a question of what sort of curation process is involved. Do we simply say yes or no to the metadata? Do we validate it by hand? Do we validate it automatically using a set of predefined rules? Once your data is published, do you want it to be accessible to anyone without authentication? Anyone who can sign on? That's what we call public. Do you want it to be embargoed, just shared with a set of collaborators? You can imagine, I'm sure, other sets of policies under which you'd make the data available. And then finally, and this we view as being largely outside the scope of our service. we assume that you're going to eventually publish data to a particular storage system, and that storage system may have different policies governing it. You know, at the one extreme, you might publish data, if you like, to the scratch storage on your local research computing center, so that your colleagues can discover it. So that's not going to last very long. At the other extreme, you might publish it to some national facility that guarantees your data will live well, forever, in quotation marks. And in between, you can have data that might live for the project lifetime, you know, according to the policies of some archive. So that's the general scope of things we want to do. And then what we're going to have available next month. So if you can read the color scheme, things in green are things we will provide by default to everyone. Things in yellow are things that we can provide, but we'll need to give you some help to implement them. So, for example, domain-specific metadata. We don't yet have a set of web pages to let you design your own metadata, so we will need to help you with that. And then some things like machine-validated metadata we're planned, but are not yet finished. So, but we already have quite a bit. So we've got, we can use bit.ly URLs, handles, as a identifier or DOIs. We support a variety of different DOI providers. We support both a range of different standard metadatas, and we allow for the integration of custom metadata with some effort from us. We allow for both human validated and automatically accepted metadata. Machine validated is to come. And then access can either be public or constrained to a set of collaborators. So embargoed would imply that there'd be some automatic process that the data would become publicly accessible after a certain time period. So that's something that we'll be adding. Later, we think it's going to be important for linking with journal publications, for example. And then, well, we support a variety of different storage systems, except forever. We're not quite sure what that will mean. Perhaps there are new methods that need to be dealt with there. Okay, so a lot of stuff going on. As I said, we've been working with a set of 8 different groups on testing this out. Basically, we've been applying it in settings in which the data sits on a research lab computer at a research computing center at a national facility, where the curator is the PI, a librarian, or a project owner, where the metadata ranges from basic Dublin core to fairly sophisticated project metadata. So we're getting a fair degree of confidence in the usability of the system. We know there's still a lot more to do, but we're excited with where we are. So at this point, I think we're going to go ahead and do a little demonstration. So I'd like to welcome Professor Tiki, who is going to play the part of a PI at what should we say, a U.S. institution.
My alma mater.
Your alma mater.
My
yep.
alma mater.
Yep.
So I'm Steve Tiki, for those that didn't see me this morning. So what I'm going to show off is our Globus publication capabilities that we're going to be rolling out in the next month or so, and take you through kind of a use case of, I'm a professor at a university of my alma mater, Wasamata U, and I want to create a collection associated with my lab where people in my lab can publish their data, make it available to other people in the lab or publicly available. So let's go ahead and do that. So I'm logged into Globus, into the publish site. And I can do searches and various things here against our search tool. I'll show a little bit of that later. But let's go ahead and create a new collection, right? So in what we'll be shipping in GA, we'll have this ability to allow users with the right permissions at your institution to create their own collections, to manage the process of collection creation. And the terminology is that a collection is a set of data sets with these various policies about, you know, what identifier schemes, what metadata, all these sorts of things about it. So you can see here we've got a community, which is the university, that I'm an admin on. So I can go in to see some more information about this. I can configure some information about this community if I want. We can create sub-communities, all stuff like that. But let's go ahead and create a collection. So I'll go to let's go back to they put me at the low table here. Go into the community and say, let's create a new collection, all right? So now, collection has a variety of things I can associate with it. I can say, what's the collection? So I'll call it the Tiki lab data. And I don't know, what's my area of research? My area of research is moose videos. I have various other things, you know, introductory text, license things, so I can say, you know, anybody who submits this data set, any data you submit here, I own. And I'll redistribute under the Creative Commons attribution license. Right, so I can set various license terms about people submitting into my collection and then how things are, what terms when people download from the collection. Various policies I can set against this. Again, to these various sliders, if you will, on this, on Ian's chart in the middle here, right, I can set various things that control aspects of how I've configured this collection. So at the top here, we have, for example, the data set storage settings. You know, this relates to the preservation, right? Where do I want to store my data? Is it, you know, just on, you know, my laptop? Is it on my campus research computing system? Is it some national storage facility archived, you know? And again, that sort of determines what levels of preservation and durability that data may have. So in this case, what I've done is it can be any shared endpoint, right? So we leverage all the same functionality that we've built up over these years. And so in this case, I've created a shared endpoint called Tiki Lab Collection, which is hosted at my Wrapup storage, which is the research computing center for my university. And one of the things, a new feature that we just recently added, is what we call access manager roles. So what I can do is say on my shared endpoint, I can give other people rights to manage the access control lists on my shared endpoint. Why that matters here is what I need to be able to do is say the Globus Publication Service, I want to give it rights to manage my shared endpoint, to set access controls on that, to put things in that data. Right, so that's what I did here, is I gave the Globus Publication Service access manager role on my endpoint. But this is actually a general new feature we've got so that you can do this yourselves on any of your endpoints. You know, have your, you know, if you create a shared endpoint and have a colleague that you want to be able to use this shared endpoint and set access control rights on, you can do that yourself, all right? So I've got this shared endpoint, so let's go ahead over here, fill that in. So Tiki Lab Collection. Data set prefix. So essentially the model we have is when data is published into this shared endpoint, it will create a folder under that for the data set. And it'll be named 1, 2, 3, 4, and I can put a prefix on it. So I'll call it datasets, dataset underscore, right? So now I've sort of configured the storage parameters of this collection. Next, I can go down and say, let's look at identifier schemes. We have various, three different types of identifiers that we support. Again, related to the top slider up there. On the right side is DOIs, digital object identifiers, which are managed under this, under the DataCite, you know, international organization for managing persistent identifiers. Handle, which is another commonly used identifier scheme. Or I'll actually pick bit.ly here, which is a URL shortener, but effectively gives you little URIs to refer to your data. And you'll notice there's a few of them have been defined for me. These are actually defined at the community level, at that Wrapup community level. But I could, if I wanted to define, create my own bit.ly scheme or handle, shoulder, or whatever DOI in my campus shoulder, right, I can create those in my collection as well. So I have control over what identifier scheme I want, depending on sort of who I'm sharing to and, you know, why I'm sharing, what my policies are. Various workflow settings. So the first of these input forms, this is the metadata. So that's the description, the second row up there, right? So I can say, what metadata do I want? Again, we have a set of standard schemas built into the service. DataCite, a few different levels there, mandatory, recommended and optional Dublin core. And then as Ian mentioned, one of the features we have is with what we're shipping next month, you'll be able to self-help pick these standard ones. If there's custom metadata you want, contact us. That's essentially a consulting engagement. And you can see here, Wrapup had contacted us to create one for climate data. So that's some specific metadata for particular groups there, so they could select that. But let's just pick one of the data sites. We'll pick the mandatory plus recommended. Similarly, workflows. We have some standard workflows. We got one that we're planning on finishing off before we ship around, for example, citation lookup, where as part of filling in my metadata, I can go out and search various article publishers to find citation information for this common workflow, which is I want data set associated with an article I just published. But let's just pick the standard workflow for asking me for data and all that sort of stuff. Curation. So this third line here, that shouldn't be description, that should say curation on that third line. Right, so I have various options for curation. All right, I can say I don't want any curation, meaning anybody who submits to this collection, it'll automatically publish in the collection. I can just have simple accept reject curators. I can also have curators who have full access and edit capabilities on the metadata and data itself. So if I make mistakes, they can correct it and stuff like that. So let's leave it at the accept reject. If I've got curation turned on, then I have various controls as to who has rights to things. So for example, I'll say I'm going to restrict the submitters to only people in my lab. I'll leave access to the data to all users, and then I'll set curations to just my lab managers. So the way we set these sorts of things is we use groups, standard Globus groups. So let me go ahead and set the submitters. I search for Tiki lab. There's a group I created out there just in the standard Globus group system that many of you saw this morning. So I'll say anybody in Tiki lab is able to submit to this. And for curators, I'll say that only the Tiki lab managers have curation rights. So I have to, or those that I delegate, have to approve any submission into this. So again, search for, we'll pick the lab managers. All right, so now I've got my collection all configured. Go and update that. And now, if you scroll in here, we see we've got a new collection within the Wrapup of Tiki lab data of our Moose videos. So at this point, now my postdoc, Ian.
Yes, your humble postdoc. Yes, please, Professor. May I have the honor of submitting some data?
I don't know, it depends how I feel when I accept it or not.
Okay. Well, let's see what I can manage. So is this going to, what do I need to do here? I've got a, is it showing up?
Yep.
Oh, it is. Okay, good. Right, so I'm already logged into the Globus website. And so now, but actually what I need to do is to go to the, I guess the demo site, right? The demo,
yep.
Publish. Globus.org, okay. Because it's not generally available yet. Okay. Okay. What do I do? I say proceed. Yep, okay, good. Log in. I'm logged in. So now here I am. I'm on the Globus Data Publication and Discovery site, so I could start searching around, but because time is short and I want to get to the pub before it closes, I'm going to start my new submission straight away. So here we are. So I'm going to submit. What have I got? I've got this, actually the right to submit to 3 different labs, but Tiki pays my salary, so I just decide to submit to his Tiki lab. And so what do we happens? Well, we start going through the workflow. First thing is I get asked to grant a license to the data I'm going to upload. Any data you submit here I own, okay? Of course, you could have a different license if you wanted. And then we get straight into the thing. So I'm going to say, this is my very exciting experiment.
So this page here is the data site mandatory fields and a standard form associated with that.
015. and the publisher is Ian Foster, humble postdoc. Okay, very good. So that's that. There's some additional things, so I can have dogs, nanoscience, you'll see why later. Description, deliberately, how do you say it, deliberately left blank?
And these fields are the DataCite recommended fields.
I'm going to upload a set of images. I've got a contributor. I'm the contact person. I could associate a related identifier, like is cited by, if this could be the persistent identifier for a paper that describes this data set. Eventually we will have a lookup process for that. We don't have that yet. So I'm going to proceed here. So at this point, I've defined the metadata. So this is all just typing things into web forms. But now we're going to go ahead and assemble the data that's going to go into this data set. So now we switch back to sort of mainstream Globus, if you like. I'll switch assemble data set. So what happens here? So we see on the right here, this is the usual Globus transfer screen. On the right, we have a custom endpoint that's been set up just for me. I'm the only one who has access rights to it. For data set 14, so the 14th data set in Tiki's lab. He's a very, well, his students, I'd say, he doesn't do much, but his students are very hardworking. So
coming to the pub to meet with me, right?
What?
You're coming to the pub to meet with me.
Oh yes, that's right. I go to the pub to meet with you. Yes. So anyway, so now I just have to say, well, where is this file? Where are these data files that I want to upload? So they turn out they're on an endpoint actually here at Argonne National Lab. I've accumulated them into a single directory, so I can simply go ahead, start a transfer, transfer them over. They're already there. So at this point, I've created my. I could go ahead and collect more data from somewhere else, but I'm done. So I can at this point say I'm finished with assembly. I'll go to the next step. I verify my submission. So there's the title, authors, publication year, my publisher, the subject keywords. Oops, sorry, I don't want to do that. Excuse me. It tells me what's happened to the transfers, I guess, and I'm ready to go.
Probably not going to let you because it says the transfer is still active.
Can I just say, yeah, I think it actually finished though. Can I refresh this?
Yeah.
Okay, let's refresh that. Oh, there we go up there. Okay. Well, let's see what happens. I thought it had finished, but anyway, let's see. Submission complete. Okay, so I could now go submit another item, but I've done enough work for one day. So I go back to my data publication dashboard, and what do I find out? I find out that actually, some things I submitted previously are there, but the data I've just submitted is still in the workflow process because it's been submitted to the lab, but Tiki has not yet reviewed it.
Right. Recall that I was the curator, the setup for Tiki lab managers is the curators for this. So I have to come and approve this submission. So I can come and say, I see something in my task pool, something that Ian had submitted. So let's take that task. Go in, I can take a look at it. Oops. There it is, some of the metadata up here that he had filled in, some of the files and the endpoint associated with it. Looks good. Let's accept this task. If I had been granted edit rights, I could now come in and actually change this metadata if I want, but I only have, why do I keep hitting that? Accept reject. So let's go ahead and approve that submission. So now Ian's submission, it's just doing the sort of final processing of getting the metadata written out to the endpoint, getting the identifier assigned for it. You can see it assigned a bit.ly identifier to this as a unique identifier for this. Like I said, could be a DOI, could be a handle, depending on what I've selected. If I were to follow through on that, it'll take me to the landing page. So the model is that every data set that gets published, you've got the data itself living in this folder in the shared endpoint with the access control I've specified. You've got the metadata that is in the Globus Publication Service and searchable, but has also been written out into the file, into the folder. And you can see the Globus metadata file. That's actually a JSON LD file. That's a standard out there for writing out, serializing metadata into a file. So we write that out, and then we have the data itself. And I can, download this in various ways. I can say, let's use the Globus tools themselves to download to do an asynchronous transfer. So I can come select these files, so you see them there, and I could select them. Or for some new functionality coming down the pipe this year, one of the most asked for feature we've had is not only be able to do bulk data transfer using Grid FTP, but also HTTP, web-based access to all data that's on endpoints. So what we've got here is an early prototype version of this HTTP capability with endpoints built in, where I'd say, okay, I see these various files in here. Let's go ahead and pick one and bring it right up, ignoring the SSL server certs. Bring it right up in my browser, right? So that all the data now available in this shared endpoint is available via my browser, right? And so now I can, you can very easily extrapolate this from this, being able to do downloads of this through browsers. We can start plugging it under other tools that support HTTP web access, and all of that HTTP is tied in to the Globus authentication capability. So it's all OAuth protected with your Globus accounts and all the access controls of shared endpoints. Everything that works against a shared endpoint works in essentially the same way against an HTTP endpoint as we've got it here. All right, I think that's it for...
I don't know what they had to do with moose, but anyway.
Well, that's the obscure reference. We'll see if anybody gets it. So.
I was going to look at one of these, one of my own images, which I slipped in unknown to Professor Tiki. See if it turns up. Has anyone here ever done multi-threaded programming? So this is a... It explains it perfectly, right? Okay, so this goes to show that Professor Tiki's curation workflow is not very thorough.
Weak.
Pretty weak, but
I'm at the pub. What do you expect?
Okay, very good. So thanks for that. So let's see what's up next. Okay, so we showed you just about every aspect of this publication workflow, right? So we were using URLs, but we could have chosen handles or DOIs. We used standard metadata. We could have used domain specific. We had a human validated, rather weak, but human validated curation process. And we were publishing data to the public. We could have also done it to collaborators. And in this case, we assume that we publish data to a research computing center site, which might be viewed as being, having a lifetime of, say, a project. So let me just say a few words about some other things we're doing in publication. I mentioned we have 8 projects that we're working with. So one of them, which we're pursuing, this is actually a joint project between a Chicago center called the Center for Hierarchical Materials Design and the National Center for Supercomputing Applications, supported by the National Institutes of Standards and Technology. And its goal here is to create what we call a materials data facility. So some of you are probably familiar with the work of the Materials Genome Initiative. It aims to collect large amounts of data, experimental and simulated, especially simulated, about a large number of materials types and compounds. The materials data facility is intended to complement that by also providing storage for large data sets, for example, from experiments at the Advanced Photon Source, simulations, and so forth. And so this is a rather complicated picture, but basically this here is a set of collections with associated, so we assume we'll have a computational materials collection, a polymer collection, and a number of others, each with their own appropriately configured policies, submission workflows, metadata, and so forth. We'll be assigning both the handles and DOIs depending on the persistence of the data, and we'll be storing data at a variety of places. MCSA is the I keep saying will be, it already is the primary storage space for the prototype, but we also expect to be storing data at NIST and Argonne National Lab. And of course, under the covers is the machinery that you've already seen demonstrated for Professor Tiki's lab. And we have a pilot of this up and running. We've published some data from a lab at the University of Illinois. Ben Blazek led this process, focused in particular on some thermal conductivity data, and we'll be adding soon some more data sets from the advanced photon source. So that's something that we'll be rolling out over the next several months. Two other data publication examples that you'll hear about in talks. So this little thing here means that there's going to be a thunderstorm. No, it means there'll be a lightning talk. Were you told earlier what to do if there's a thunderstorm and a tornado warning? I assume you were. What are we supposed to do, actually? I should know. Don't go outside. Yeah, so I apologize for not knowing that. Don't report me. So we'll have a couple of lightning talks, one by a group from New York University, one from Compute Canada, or Calcul Canada, talking about the work they're doing with the publication service. Okay, so that's enough about publication. Now let me just talk about a few other neat things we've rolled out over the last year or so. So one is we've enhanced data sharing. So you saw that earlier, very briefly perhaps, but so we've always allowed people to share data, an endpoint that is, share an endpoint with a particular user or with a group. So we've added a couple of things. One is the ability to share with all users, basically make the data globally, publicly accessible. And the other is to add email sharing, so that if I don't know someone's Globus user ID, I can simply send an email to them and they get access to the data. The other thing we've added is, Steve already referred to, is this access manager, which allows us to start to provide a richer set of roles for people who may be involved in managing publication services, endpoints, and so forth. Were we going to do some more demos?
We're going to do a demo with this one.
Yeah, okay.
Yep.
So you are, I think. Yeah. Yes.
Nick, you're going to share to me.
Oh, I'm going to share to you. That's right. Yes,
right.
yes. I forgot about that. Yep. Okay. So, so what do I want to share with Steve? With Professor Tiki. So, so I'm going to go back to the globus.org site. I guess I'll blow it up a bit here. I'll go to transfer files. So here I have, let's see, what shall I do? I'm going to create shall I create an endpoint from scratch, do you think? Is that,
sure.
Yeah, why not? So let me go up a folder. So I'm going to create a new folder. We'll call it for Steve. Create it. We'll go in there. We'll put something in there, that nice picture of dogs. And now I'm going to go ahead and, what am I going to do? I'm going to...
It's like sharing is not turned on Petrol.
Oh, it's not sharing, it's not turned on Petrol. So I should go to UCRC. Yeah, yeah. I want to go to UCR Midway? Yep, okay. Okay, yes, so here I think I'll just go to share. And I'm going to share this endpoint, which is so far empty. So I'm going to add a new shared endpoint. I'm going to call this, well, I'll call it Steve. How about that? I do that. This is data that is not to be shared. No, to be shared. Sorry. Then I go ahead and create and manage access. So I've got a new shared endpoint in this. Basically, I've turned this directory called share on the Midway endpoint into a shared endpoint. And so at this point, I want to add permission to it. So of course, I could go through and select a user. I could select all users. I could select a particular group, or if I knew someone's username, I could use that. But I'm going to send email to demo@tiki.com. Oh, I'm not a very good typer, as you can tell. Okay. I'm going to grant him read access, so I simply add, send it off, and so at this point I've sent an email invitation with right now is wending its way through the ether to wherever Steve may be located. I'm going to meanwhile transfer a file into this folder that I've set up as a shared endpoint. I could move other things, I guess, just in case he wants something more than just pictures of dogs. So now he's got a couple of files there. Have you received your invitation?
Nope, it's still working its way through the tubes.
And you can see down the bottom here, of course, I've got a couple of transfers that have completed. I could go and learn more about them while we're waiting. It moved at the grand speed of 2 megabits per second, not very fast, because of course it's not a very big file. But I will show you some more impressive ones here. Let's see, this is a transfer I did yesterday, 300 megabits per second. Are you done yet?
Yeah, I got it.
Okay.
Go ahead and show your 300 megabit per second. That's cool.
I've got a gigabit per second down here somewhere. Depends how much other people are doing. There we are, 1.2 gigabits per second, moving 10 gigabytes from Berkeley to Argonne. We should be doing even better, but that's not bad for a starting
Now that's
point.
also measuring complete end-to-end time, including verifications and everything else. So, all right. So meanwhile, over here, I am sitting in the pub, and I got my invitation to the shared endpoint. Right. So you can see Ian's invited me to this Ian Steve endpoint, and it says to accept it, just click on that. So I'll go ahead and click on that. It takes me over, says, yep, your share is now ready. Go ahead and click, and I now have access to that endpoint, so I can now go off and do things with it. So for example, I can go to nurse DTN, which is an endpoint maybe that I've got access to elsewhere. I'll take one of these files and download it. But I also want to load something up to that endpoint. So I want to create a folder here. But Ian hasn't given me access. So Ian,
you don't really deserve it, but we'll see what we can do. Okay. What a fine patter we have going on here, yes. So I'm going to go to this endpoint, and basically all I'm going to do is to set write access.
At which point I can try it again, and we have write access. Click on it. Now I can take some files and upload them up into Ian's endpoint.
Okay.
So that's all there is to it. Looks like it's still transferring. And that's it.
There it is, folder 1. Very good. Yep, it's there.
It's there.
Okay, more or less. All right, very good. So thank you, Professor, for participating. My experience is professors don't usually know how to use computers, so you've done very well today. So that was the data sharing enhancements a demonstration. So I'd like to just say a few other things that we've been working on. So some things that relate specifically to resource providers, people or institutions that run Globus endpoints for their user communities. So we've enhanced the properties of the management console. I'll show that to you in just a second. Basically now you can monitor what tasks are currently running, search, find tasks that have failed, and so forth. Soon we'll have the ability to actually do more fine-grained control, so you can go in and if you see that something important is going on and you need to delay other transfers, you can pause them. If you see that your academic enemy is moving stuff, you can stop them until you're done with your transfer. That is if you're the system manager. We've added, this has been something that a number of people have been asking for, more control over endpoint concurrency and parallelism, so that if you have a endpoint with multiple data transfer nodes configured, you can set up to use them, multiple of them at once. Sometimes it's useful also to modify these parameters to meet the particular properties of your network. There'll be a talk on the Network Manager plugin a little bit later, some very interesting work being done there. And then finally, very soon, we'll be rolling out streamlined account provisioning. So the basic idea here is, well, let me explain the idea. As I think you probably mostly know, in order to use Globus at the moment, you first of all sign up for a Globus account. Then you link your InCommon account to that, perhaps, and your Exceed account or whatever other accounts you have. And then subsequently, you can authenticate to Globus using your in-common account, your campus credential, or any other account that you've been able to link to it. But you do have to do that original account creation. So what we're very close to finishing up, we need this for a number of projects that we'll be rolling out soon, is basically eliminating this need to create a Globus account in the first place. And this is certainly one less thing for people to do, first of all, but also it's going to make it possible to auto-create accounts for people. So for example, a campus can set up and basically just create an account on Globus for everyone who has a in-common credential on their research computing center. So it will reduce yet another barrier, yet another piece of friction to the use of Globus services. So we thought it would be good just to show a few words, say a little bit about this management console. So how many here have seen the management console? So a few of you have, but it's pretty cool. So let me bring it up. So the idea here is that basically there are who are the users whose lives we want to make easier with Globus. We want to make the lives of the people who are engaged in research, data creation, and management. We want to make their lives easier. That's the end users. Those are the ones we've been focusing on here. But we also want to make the lives of the people who run research computing centers and so forth easier as well. And so the management console provides a set of tools for the people who are responsible for administering computer systems. So the basic idea of the management console is that you configure it in order to, so it would normally be configured to display information about the endpoints that you as a system administrator are authorized to monitor and manage. I've got mine set up to know about the endpoints of a few friends of mine, friends at NCSA, at NERSC, at Argonne, that's the petrol system, and at the University of Chicago Research Computing Center. So you see more here than you normally would see, but it gives an interesting perspective on what's going on. So what are we showing here? We're showing on the left a set of endpoints that I am monitoring, that I'm authorized to monitor. For example, NERSC. So if I mouse over it, I'll see what's going on there. I can see, I don't know if you can read the fine print, there are 3 tasks currently active involving roughly 9 million files. Is it going to come back? Yes. With 3 remote endpoints, and I can even see the remote endpoints. One is Sloan Digital Sky Survey System, and 2 others I don't recognize where they are. If we go to NCSA Blue Waters, you can see actually there's 114 transfers active currently to 11 different endpoints, but not involving so many files, only 12,000 files in total. So the left is the source, is the monitored site, and the right is the partner of that monitored site. So if I wanted to see more about what's going on at, say, maybe I should choose. Well, I guess the UCRC is no longer visible because it's not engaged. Its transfers are finished. So that maybe I should pick, say, NCSA Blue Waters, and I can see over here now. I'm just seeing the activities that are underway. Here, I can now go up here and I can start to zoom in. I can start looking at what tasks are currently active. So basically now we switch to a view that doesn't provide this overview, but rather allows me to zoom in on what's happening at a particular endpoint. And basically I can add a set of queries. I can see what transfers have had faults, for example. I can zoom in on a particular user and see what activities they've been engaged in. So these are activities by this particular user with faults that are currently active. So I can get rid of some of these and find out other things. So this current user has got a lot of currently faulty transfers, and you can actually see why. Globus Connect is offline for one of them at least. But in the past, they've obviously moved a lot of data quite successfully. So we can zoom in and get different views on the activities of an endpoint in a manner that's designed to provide the manager with a high-level view of what's happening, which will allow them to, well, currently detect problems before perhaps end users detect them. And in the near future, they will also be able to go in and perhaps deprioritize, suspend certain transfers if if there are so perhaps one user starts too many activities, more than is deemed appropriate. Okay, is there anything else I should show? I think that's good. Let's. So that's the wonderful world of the management console. Let me say a few other things that we've been doing recently. So another frequent request is adding support for transfers to and from Amazon S3 endpoints. So the Globus logic sits on Amazon computers, as I've said, but the data that's being moved around sits on storage systems that may live anywhere. Well, one place that people increasingly want to put data is on Amazon. So we've added support for movement of data from any Globus endpoint to an Amazon S3 hosted endpoint. So we got it working, integrated it with our security. We've been working to optimize performance, so we can now get multiple gigabits per second, at least from places like the University of Chicago, where there's a high-speed Internet 2 connection into Amazon. That's for public cloud. We have a project now funded by the National Science Foundation that will add support for, allow us to add support for OpenStack Ceph object stores. So we'll also be able to support some classes of private clouds as well. This has been developed initially for the NSF Exceed Jetstream private cloud system to be installed at the University of Indiana. So just a few, so this is what it looks like, right? So here I'm transferring data from, the University of Chicago Research Computing Center, Midway Cluster, or to or from a S3 endpoint. We've got up to 2 gigabits per second sustained. Basically what we're doing here is doing multi-part upload, download using multiple concurrent HTTP connections in order to achieve high performance. So 2 gigabits I think is pretty good. We've also done some work where we stand up a GridFTP endpoint on an Amazon EC2 and then access move data to and from Amazon S3 directly from there. And then we can get up to 5 gigabits per second peak, and I think something like 3.5 gigabits per second sustained. So we're quite pleased with that as well. So you can move your data to and from Amazon now. Another thing that we keep being asked for is support for Amazon Glacier. So that will, I don't know if it's scheduled, but it will come at some point. Some other things that are going on. So this is not something you'll necessarily notice, but under the covers, we'll come back to that in a second. Globus has a pretty rich and very powerful and reliable, scalable set of technologies for managing users and groups. So we initially built this on top of our own homegrown graph database. We recently moved it to PostgreSQL, which has allowed us to actually achieve higher performance and leverage some nice properties of Amazon to improve reliability. And then we're in the midst of moving to Ember.js for web application support. And that's not something I know much about, but those who are interested, anyone interested in learning more about that? So say yes, because the people who did it are here. Anyway, I was going to say they could put their hands up and you can go and talk to them. But this is going to be really, really cool. So I was smart enough, this original slide, it said IN8N support. And I thought not everyone will know what that means. So I spelled out internationalization correctly, I think. Okay, so big picture. We've over the last year, since we last saw you, we've added some really exciting new stuff like publication is now working. And then there's a whole set of things that have happened under the covers. We've just mentioned a few, but the fact that we can now move data to and from S3, that we can we have more scalable group services. We can do email invitations on groups. All these other things I think are really exciting and make the service more interesting. So, but that's really, I want to wrap up this discussion now and move on to one more thing. So, so what I've been describing so far is, Globus is as a software as a service system. So, software as a service is basically about taking some activity that you used to do by hand or using locally installed software like managing data transfers and handing it off to someone to do it for you. In this case, us being the people you hand it off to. So we're software as a service for research data management. And you can use our web interfaces, as I said, to order up data movements and data publications, just as you'd order up a book delivery from Amazon. But it's also, we also want to communicate that Globus is also increasingly, we think, a platform as a service system. So what do we mean by that? Oops. So what we mean by that is that, well, the first order, various of the functions that you and others as end users interact with via web interfaces, you can also invoke via APIs and thus hand off responsibility from your applications, for example, your science gateways, to us to take care of for you. And in so doing, you end up being able to, we believe, reduce the cost of creating a wide variety of applications. So if we think of all the science gateways that people have built over the years, how many of them have built into their science gateway some logic to manage movement of data from one place to another? Quite a few. How many have built in their own mechanisms for managing groups? Quite a few. How many for managing identities? Maybe even some have built in logic for data publication. These are all things that one can outsource, if you like, to our Globus platform as a service offerings. So we haven't been sort of talking too much about this, although a few projects have been using our APIs in this way for a while, but we plan to make this more visible in the coming months. Initially, we'll be focusing on basically the transfer, OAuth, and group membership APIs. So that, well, I'll give some examples in a minute of what that means. The streamlined account provisioning is going to be an important part of that, as I'll explain in a second. Over time, we'll add other APIs. There'll be an API for publish, for user profile management, and for other things. In the near future, sorry, I should maybe stop using that. It's dangerous. Okay. In the near future, we'll be putting up a dev.globus website. It doesn't exist yet, so don't go looking for it. But this will provide code examples and documentation and so forth for the use of these REST APIs designed for developers of applications and others who may be interested in this. Let me just give you one example, or I'll give you a couple of examples of how these things are being used today. So this is the NCAR Research Data Archive is a system that you'll hear about in a lightning talk a little bit later. But they've been using the API to really streamline and accelerate the process of downloading data from their site. So the Research Data Archive has, I think, something like 1.5 petabytes of data on online storage. People can come in and search for it using something like the orange part on the right there. Once they find some data that they like, they select it, and then they want to download it to their local computer system. So this used to be a rather convoluted process where basically there was a synthesis of a wget script that you would download and run locally. With the new system, Basically, the RDA system takes you through the process of finding the data you want, then automatically creates a shared folder, basically a shared endpoint that's dedicated just to the requesting user, sets the permissions on that folder so that that user can access it, moves the data into it, and then emails a pointer to the new folder to the user. And the user can then click on it and download the data at high speed using Globus. So, so basically they're using the group management API, the data transfer API, and the sharing control API, so to enable this process. So a very simple set of calls inside their application that delivers a very powerful set of functionality. Another project that you'll hear about from another group here is the work on Globus genomics. So we've talked about this in previous sessions. So this work led by Ravi Maduri and Paul Davey and involving a number of others is a project that is designed to deliver easy-to-use genome sequence and actually other biomedical data analysis applications on Amazon using the Galaxy framework. This, rather like the previous system, although for a very different purpose, uses our APIs, basically outsources to Globus the task of authorizing users, managing access to endpoints and to Galaxy platforms, and moving data to and from the sources. That might be a sequencing center to the data analysis location, the Amazon cloud typically, and also then moving results out to users' home institutions if they so desire. So over the last year, I think since we last talked, this group has processed more than 2,000 genomes, processed a petabyte of data, used 4 million CPU hours on Amazon. So a fair bit of computing going on and increasingly streamlining the process for users thanks to the use of these APIs. Okay, so that's just a few words about Globus as a platform. We hope that some of you here will be interested in pursuing that further. We are really excited about the opportunities to take the power of Globus and apply it to reach a lot of people by embedding it into applications that already do great things, but that could do them faster or more easily in this manner. I have a couple more things to talk about before we wrap up here. So first of all, a few words about something we brought up last year, and that is the one of sustainability. So I wanted to explain where we are. I think we've made some good progress in this space. So as the big deal on sustainability is, as we say here, we're a non-profit. We work for the University of Chicago. Some of us work for Argonne National Lab. Globus is not a corporation. It's just, if you like, a service unit within the University of Chicago. It operates this very powerful service for the research community. We believe that the right thing for us to do is to keep doing that rather than trying to spin off a company or something, because we'd inevitably end up being forced to do things other than serve the needs of the research community. So we have this nice idea of a non-profit service for the non-profit community. The question is, how do we sustain that? Well, we don't sustain it, we believe, by writing lots and lots of proposals to the National Science Foundation and National Institutes of Health and DOE. We can do that to deliver new features, but typically not to operate the service going forward. So we need to find a way to support that operations process. And the approach that we've been taking is what people in the biz sometimes call a freemium approach, right? We provide the service available to everyone. Anyone can move data using Globus, but then we provide some premium features to institutions that want to sign up as subscribers. So what are these premium features? So if you want to get access to this management console, you need to be a subscriber. If you want to host shared endpoints, if you want to engage in data publication, if you want to move data to S3, et cetera, et cetera. Some people want branded websites so that rather than seeing the Globus page, they see the NERSC page or the Blue Waters page. These are two people who've signed up for this. Some people want to integrate alternative identity providers, so you can just authenticate using In Common, for example. And then a number of high-end sites want mass storage system optimization. So we can do special things to move data rapidly to and from mass storage systems. We reorder transfers to take into account layout of data on disk, for example. So if you're, so our basic approach to sustainability has been to make data transfer free to everyone, provide some of these additional services to institutions in return for a subscription. So last year we also talked about this wonderful book. How many have read this book, Crossing the Chasm? I mean, I think it's well worth a read, even if you're not interested in starting a company, which actually I'm not interested in doing, but it's nevertheless interesting. It talks about the challenge of getting a new technology from the point of which I think many of us who've built software over the years recognize, where you've got some, the first step when you release a new software, you meet these, you start talking to people and they think it's the best thing ever and they start using it and you think, wow, now I've got it made. I found two people who think this is wonderful. But you don't realize that these are actually technology enthusiasts. And first of all, there aren't very many of them. And secondly, they tend to move on to the next thing they're enthusiastic about. So it's not necessarily a path towards long-term sustainability. What Geoffrey Moore talks about is you need to move, basically you need to get to this point where there's you don't want the real conservators will take a long time. They won't use your software until every other person in the country is using it. But there's a set of what he calls pragmatists, people who, as long as you've got a whole product and it's robust and easy to use and it addresses a well-known need, a need that they really have, then they will adopt it, even if not everyone else is using it. So this challenge he talks about is getting from here to here. This is what he calls crossing the chasm. And last year we said we felt that we were basically around here in this path. We'd got certainly a number of visionary sites who were signing up and using the service, but the number of subscribers was very small. Were there any a year ago? We were just starting the process, I guess. Yeah, one or two visionaries. So where are we now? Well, one thing we got support from the Sloan Foundation last year that was aimed at helping us across this chasm. We feel that we have got to the point now where we have, certainly some very welcome and interesting visionary adopters, but also some real pragmatists, sites who see it providing value. Furthermore, they've come back and renewed a subscription in a number of places, which suggests that we are onto something more long-term. We're still not certainly at the point where we've got to full sustainability, but as we say here, we've got more than 30 annual subscriptions, ranging in size. So some big high-end sites who have a lot of stuff going on are paying us $100,000 a year. Not too many of them, I must admit. And then some are much lower, so you can start at a very low level. But together, this is getting us, at least making us feel good about this notion that we'll get to wherever we need to be, maybe up here, in order to achieve full sustainability for the service. I wanted to mention one other sort of business aspect to things, and this is some thoughts we've been having, and we just mentioned this to get people's reactions to the challenges of what we call global data management needs. So, how does Globus work at the moment? Well, it's run by us at the University of Chicago with all of the code and the software and the data, the metadata, user data, sitting on Amazon storage. So it's professionally run, it's highly reliable, secure, but nevertheless, particularly when given recent events or not so recent events, some countries feel a bit uncomfortable about the fact that their metadata is sitting on US servers. So some countries in the EU actually have laws that may prevent you from using a US hosted service. And then in the US, there are things like, say, HIPAA the Health Information Protection Act, DOE, which has sensitive, unclassified, and classified data, where they again would not be comfortable with some group of University of Chicago people managing access to their data. So how do we deal with this? Well, the approach that we've come up with, I've said this, is this notion of a federated operation of the service. So we've been exploring this a little bit from a technical feasibility perspective, also talking to some potential franchisees. So the basic idea is you have, again, a single copy of the software, as in software as a service, but you run multiple instances of it in different legislative, administrative domains. So they might be running on, say, a European or a Japanese Amazon domain, if that's viewed as acceptable, or perhaps on some totally different cloud provider that is not owned by a US corporation. And similarly, NIH could run a version of Globus in the .gov cloud, which has a higher security. So we're just in the early stages of exploring what may be possible here. We've had some interest from a number of countries, well, people in countries, not entire countries, I guess, but several continents have expressed interest. So we may well end up managing to push this forward. So I should say 2 continents and 1 very small Pacific island nation, not to be named. Okay, so so let me wrap up. So I've explained our vision. We want to accelerate research and discovery, innovation, and we believe we can do that by reducing the costs, slashing the costs, reducing the friction associated with research data management. And the way that we're pursuing that, and we think this is the right way to do it, is by this use of cloud-based services, so that we can do for research data management what other organizations do for more mundane things like buying books or pet food. So we're excited with how far we've come. I should say we've come this far thanks to, well, first of all, a set of sponsors. So the NSF, NIH, DOE have supported us. The Sloan Foundation has provided some vital support for bridging crossing the chasm, bridging the chasm, I guess. We've also benefited from direct support from the University of Chicago and Argonne, and we get a lot of support from Amazon, who help us run our services on their computers. I should also say, though, equally important has been the support from people like yourselves. So, Globus wouldn't exist if it wasn't for our more than 25,000 registered users, the many campuses who provide the service to their users, the many people, the growing number of people who are developing innovative applications, the subscribers, because they're the ones who actually let us pay the bills and give us a hope that we will sustain this into the future, and of course you all for coming to this meeting. So thank you very much for attending.